Hello students, this video is designed to help you review Unit 7. We're looking at the problem sets from Lesson 6 through Lesson 9. Just like with all the other videos, try to do these problem sets first, then pause the video and see if you got the right answer. So do that now. Alright, in the Lesson 6 problem set, you should have known that we were working with the altitudes rule. That was that lesson, altitudes rule lesson. It works for right triangles, and it says that the part over altitude equals altitude over other part. These parts that we're talking about are the parts of the hypotenuse. So if you look at this hypotenuse here, one of the parts is x, one of the parts is y. And it doesn't matter which part you start with as long as you alternate, and as long as the altitude goes on a diagonal here. So, for example, this has z on the diagonal, and it also has x up here, which is one of the parts, and y down here, which is another part. It's not this one because it asks us to do part over other part, and c is the whole entire hypotenuse. The other ones don't have the altitude on their diagonal, so see you later. Question number 2, it asks us something very similar. I identified here the part and the other part, and you know that this is a right angle because it tells us it's a rectangle. This is another example of just setting up the proportion correctly. Here's another set up the proportion correctly question, but it tells you the whole hypotenuse here. It doesn't give you this part. Well, if this part is 10, the whole thing is 24, you got to subtract. Fairly straightforward. Question number 4 asked you to set up the proportion, which I did here, and then solve. You should notice that sometimes you'll get an x squared equals some number. We have to square root both sides. In this case, it was a perfect square. In some other cases, we would have to simplify the radical. And in extreme cases, we would have to set up a quadratic equation and solve for x by factoring. In question number 5, I wanted to draw it out for you here. So it tells us that PRQ is a right angle. Don't panic if you don't have the picture, because you can easily draw a picture like what I'm going to do now. It says PRQ is a right angle, so the first thing I'm going to do is I'm going to draw a right angle, and that right angle is going to be PRQ. So I'm going to label it up here. This one is P. Let's use red, shall we? Keep it consistent. This one is P. This one is R, and I know R is supposed to be in the middle. Again, it is in blue. So annoying. And we know that the last letter is supposed to be Q. There we go, fixed it. It also tells us that RT is drawn perpendicular to hypotenuse PQ. Well, if hypotenuse PQ exists, that means we're going to need a line from here to here. That's going to form our hypotenuse, and we need a line that is perpendicular to that to serve as the impromptu altitude. Now it tells us that PT is equal to X. Well, we know that this point here is T, so let's label it as T. It tells us that PT is equal to X, so the X goes here, and this is going to be a lowercase x. It also tells us that RT is equal to 6, so we're going to put 6 here, and TQ is equal to 4x. Well, look at that. It just gave us the two parts and the hypotenuse. So the proportion that you're going to set up is going to look like this. So we're going to do part divided by the altitude is equal to the altitude divided by the other part. When we cross multiply, we get 4x squared equals 36. That's over here. We also see that when we divide both sides by 4, we get x squared is equal to 9, and then square rooting both sides, of course, that's what we're doing here. We're going to get x is equal to 3. That's what we did here. We square rooted this side, and we square rooted this side. Those are perfect square root symbols, no complaining. All right, so x is equal to 3, but 3 is not the answer because we're looking for the length of PQ. This piece is 3. This piece is 4 times 3, which is 12. So 12 plus 3 is, of course, 15. Move on to the next page on that problem set, pause the video, see if you can do it, and then come back and see if you did it right. This one was fairly straightforward. It gives us these two measures, and it asks us to find BD. So we set up the proportion with the altitude in its diagonal here. We cross multiply, and then we find we can't take the square root of 80 easily. But what we can do is break it into one perfect square, the largest perfect square that goes into 80, and also the leftovers. So 16 times 5, as you know, is 80. We also know that the square root of 16 is 4, and the square root of 5 we cannot do anything to, so we leave it like that. The next question gives us a ratio of 1 to 5, but this ratio is very easy to work with because it says AD to AB is 1 to 5, so AD is going to be 1x, and AB is going to be 5x, which means if this is 1x, this is 5x, then this piece, DB, must be 4x. So we do part divided by altitude equals altitude divided by part. That's this here. We cross multiply, and this should look very similar. This was almost the exact same equation on the other side. We get 3 is equal to x. Then it asks for the length of BD. So in order to find the length of BD, we take 4 and substitute, we take 4x and substitute in x. We get BD is equal to 12. Last but not least, we have a couple of steps here. The first one is the red step. I know that this triangle that's drawn here, we don't need altitude's rule or any other rule. This is the Pythagorean Theorem. We have 2 sides of this right triangle. We just need the third. So here's the Pythagorean Theorem. We're asked to round to the nearest hundredth of a mile. We're looking for the distance between the park ranger station and the lifeguard chair. That was between P and L, respectively. That's 0.49 miles, and I showed the work here. Next, I'm looking for the distance from the first aid station to the campground. Well, first aid is here, campground is here. That means this whole green section is that distance. We don't know all of it, though. We don't know this piece, which is y. So we take part divided by altitude equals altitude divided by other part. That's here. And we know that that x is no longer x. We know that x is 0.49. So we're asked whether Gerald is correct or not. And, well, we can see pretty definitively here once we solve for y, we get 0.9604. That's this piece. That means that the whole entire thing should be 0.9604 plus 0.25. That's not 1.5 miles. It's less. So Gerald is wrong. Moving on to the lesson 7 problem set. Again, pause the video, take a look, and then come back when you are ready. Alright, in lesson 7, it was all about the legs rule. I modified the legs rule a little bit so it's a little bit more easy to see. We're talking about the large hypotenuse over the large leg equals the small hypotenuse over the small leg. So in this case, we're talking about the large hypotenuse, which is 36 here, divided by the large leg, which is 12. So that's 36 over 12. And then when we're looking at this smaller triangle, we see that's 12 is the small hypotenuse of that small triangle. And then the small leg, that's x, so 12 over x. We cross multiply, and we get 4 equals x. And that was the length of AD, so we're done. In this case, we do the same thing. Large hypotenuse is 15, divided by the large leg, which is x. Then we do the small hypotenuse, which is x, divided by the small leg, which is 3. Cross multiply, simplify the radical, bada bing, bada boom. Oh, you don't believe me that 6.7 is the same as 3 radical 5? Well, check this out. I did it on my calculator. 3 times radical 5 is 6.70. That doesn't round to 6.8 because there's a 0 right here. 6.7 is the correct answer. Nice. Question number 3, 2 radical 6 is your answer because, again, 12 divided by x equals x divided by 2. It's the same exact problem over and over again, just with different numbers. This is called practice. For question number 4, the easiest thing to do was to set up all of these proportions and see whether they worked. The proportion that worked looks like this. EG, which is the big hypotenuse, divided by DG, that's the big leg. That's equal to DG, which is the little hypotenuse, divided by DF, which is the little leg. Next page, pause the video, try it out yourself. Alright, this was a 2-step problem. It asked us to find the lengths of JG and JH. The first thing that we're going to try to do is find JG. We label that as x, and since we're going to be using the legs rule, we need the whole entire hypotenuse, which means the hypotenuse is 16 plus x. We set up a proportion hypotenuse of big triangle divided by the leg of the big triangle is equal to the hypotenuse of the small triangle divided by the leg of the small triangle. Notice that these numbers are always going to be the same on the diagonal. We do a quadratic. Take a few moments to parse this quadratic and see if you understand what's going on. Again, we never take negative numbers as measurements. We're always going to use the positive value. This is rejected. We call that rejected, if you remember from algebra. Anyway, we get x is equal to 9, so we have to state JG is equal to 9. Then we're able to set up the next proportion to solve for JH, which I labeled as y. I know that I'm going to use the altitudes rule now because I'm looking for an altitude. So 9 divided by y, so that's part divided by altitude equals altitude divided by other part. So I know that this one is 9 now. So I'm able to cross multiply and get y squared equals 144. Well, thank goodness that's a perfect square. Y is equal to 12, which means I have to state JH is equal to 12. Make sure when you're answering region-style questions on a test or a quiz, you state the whole entire answer, what it's looking for. Again, here, it is looking for the measurement of h. So we're going to identify that's the thing that we're looking for here. It is another 2-step problem. We don't know any of these parts, so we need to find them. So we're going to use the good old-fashioned 5 over 3 equals 3 over b. That's 5 over 3. This is the legs rule, equals 3 over b. Once we solve for b, then we're able to then we're able to substitute into the altitudes rule because the length of h is looking for the altitude. 1.8 divided by altitude equals altitude divided by, wait, how did I get 3.2? Because the whole thing is 5. This part is 1.8, which means that this part has to be 3.2. Anyway, that should be 2.4. That is the correct answer there. Question number 7 was another two-parter. This one wasn't so bad either. All you had to know was what you didn't know. I don't know TS, so that's X. I also don't know RT, and it tells us that RT is 16 more than TS. So the first thing we're going to do is find the length of TS, which is cross multiplication. Notice I went right from here to here because this was the same exact quadratic as before. Be prepared for a quadratic. I know that X is equal to 9, so that TS is equal to 9. Following that up, if this is 9, that means that this is 9 plus 16, which is 25. 9 and 25 is 34. So I know the whole entire hypotenuse now. Now I'm able to use the legs rule. 34 divided by y is equal to y divided by 25. And that 25 comes from here. 16 plus 9 is 25. I cross multiplied and notice I didn't multiply these out because I knew that that 25 was going to be my perfect square and the 34 was not. 34 is 17 times 2 only, and neither of those are perfect squares. So then I labeled RU is equal to 5 radical 34. Moving on to the lesson 8 problem set, pause the video, try to do it yourself, and then come back. All right, in lesson 8, it was just a review of all the different rules that we'd learned about so far with geometric means. This one we use the altitudes rule because, of course, it asks for an altitude. The part of the hypotenuse over the altitude equals the altitude over the other part of the hypotenuse, cross multiply, square root, all set. This case, it asked us for 3 different answers, so we tried to do them one at a time. This first answer asked for GH, so we found it by doing 20, which is the hypotenuse, over 16, which is the leg, equals 16, which is the hypotenuse of this smaller right triangle, divided by GH. We solved for GH by dividing both sides by 20, and there we go. In this case, we used something called the addition postulate. You remember the addition postulate, hopefully. It means that one entire line is equal to its parts. So, for example, I know that this whole entire line is GE, and that's equal to 20. Well, GE is equal to GH, which is this part of the line, plus HE, which is this part of the line. Seems to make sense to me. We know GE is 20. We know GH is 12.8. We just solved for HE to find 7.2. In this last one, oh, you might have noticed that this is HE, but this should not say HE, so I will magically change that. Boom! There we go. HF is the altitude, and we know that we're using the altitudes rule to find it. So HF is the altitude that we're looking for, and we know that 12.8 is this piece right here, and we know that 7.2 is the remainder right here. That's the other part. So we cross multiplied, solved 9.6. Not bad. Remember, if this had a measurement in a certain type of units, like for example, if this said 16 inches, if this said 20 inches, it would be very, very important for you to include HF is equal to 9.6 inches, but it doesn't, so we don't. Last but not least, we used a couple of different steps here. I ask you to pause the video, follow those steps, and try to figure out where all those things came from. All right, this is the second page from the lesson 8 problem set. Pause the video, try to do these problems, and come back when you're done. Here's the similarity statement. The similarity statement has to keep in mind that all the letters have to be in the correct order. So you can see the correct order here, ABC, BDC, and ADB. Here's a proof that you should know already. You remember it from the other video. It shows how to use the AA similarity theorem to find two triangles congruent. And here it asks you why these are correct. Why are these proportions true? It's because they have proportional sides. Corresponding parts of similar triangles are proportional. Now the next page is going to be the last page. This is the problem set from lesson 9. And here are the proofs. These are all proofs that require first AA similarity theorem or some other similarity theorem, then a proportion, which you can set up using corresponding parts of similar triangles are proportional, and then the last step is going to be cross multiplication. As a quick hint, these two are multiplied together, so the top of one has to be the bottom of the other, and the top of the other has to be the bottom of the first. Here's another example, and here's another example. Folks, that was the lesson on the problem set unit review. Good luck studying.